Hey everybody, this is Larry. This is day 28 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Let's take a look. I just want to give a quick minor update. I haven't, it is Monday, so, well, technically the way that I do it now is Sunday, but yeah, this contest from the other day, or from a day ago, was so exciting. I finished with 11 seconds left. It was one of those really hard contests where for basically an hour and 10 minutes or 12 minutes, I only had two problems solved. Would have been I don't think I've ever only solved two problems before on Leetcode anyway. So, but kind of pulled through, grinded through. I want to make this a point because I think, and I mentioned this a couple of days ago on another video. Man, my videos are becoming like podcasts now, or vlogging or something. But if you don't enjoy this part of it, feel free to fast forward. If I get too preachy or annoying, also fast forward or skip ahead. But my point here is that very often, I get this question of how long should you do a problem for before looking up the answer or whatever, right? And some people say 15 minutes, which is ridiculously short. I think it's hard these days to have attention span, but you have to really just grind it through. At the end of the day, sometimes if there are two types of things, right? One is two types of problems that you can get stuck at. One is problem solving, in the sense that you have every tool that you need, you just don't know how to put them together to solve a particular problem. And then the other thing is like, oh, you have to learn this algorithm by some really famous but possibly dead person. Then it's like, okay, well, I didn't know that algorithm, so there's no way to solve it. And I advocate that, and this is why it's good to have a study group. I didn't have this when I was younger. Maybe not, obviously, but still, I'm going to say that's the case. Is that you have a study group or something like this, or a group of people, and this is why and this is maybe my plug for my Discord as spam, haha. No, but if you have a question, you're like, hey, so I'm looking into, I don't know, Q4 or whatever, is there any special knowledge that you would need to know? And then someone may be like, hey, yeah, you need to, in this particular case, hopefully not spoiler alert, if you want to not be spoiled, skip ahead. But I'll be like, oh yeah, you need some algorithm, so if you don't know it, then you're never going to get it, right? This particular case, this Q4 requires sparse array. Of course, you can actually, you could actually come up with sparse array by yourself, or this binary dynamic programming, or it goes by a couple of names, but you can come up with it by yourself, but it may take a long time. And even for me, for Q4, I knew the algo immediately, but it still took me a while to implement it correctly. Yeah, so that's basically the idea. And just to kind of, maybe this is a get off my lawn, Larry is old moment. When I was younger, I did not have any of these things, and in fact, there's no way to look up the solution, because back then, your ranking, quote unquote, on a website is the number of problems you solved. So a lot of people heavily guarded. There are a couple of people who are really like generous with the time, and a lot of people that I respect, and they help me out with understanding some stuff. But it's not like something that you could just Google nowadays, right? Or you can watch some random idiot explaining themselves on YouTube poorly, huh? Like me, is my point. No, but so if you didn't get it, you're either just never gonna get it, and there's no looking it up, right? Is what I mean. So it was not uncommon for me to spend literal days to it. Maybe not like consecutive on end, but maybe I'll be stuck for like 2 hours. I go to dinner, think about it a little bit, maybe do some other stuff, go to the gym, and then think about it in the gym. So it may take me all these things to kind of think about it, right? So when I say like you have to get the practice in, that factors in it, right? Because maybe you're smarter than me at home and all these things, and you're able to be more efficient. But remember, your goal isn't always necessarily to learn something efficiently. Your goal is probably just to learn something at all, right? And if you actually understand it, if you actually learn the hows and the whys, and when to use something and also when not to use something, that's more valuable than getting it on a contest one time. You know, and when you kind of move up on your progression and you do more code forces and stuff like this will become more and more critical, because you can't just, Leetcode is kind of like that right now, to a degree, with Q1, Q2, Q3, not this contest, Q3 was hard, but you could get to a point right now where you kind of just be like, oh yeah, this is this algorithm, and then you kind of write a couple for loops, write the algorithm, and you're done. But when you get to code forces and stuff like that, when you have to transform the problem into a different way, with these problem solving things, and like kind of making observations, and like kind of almost seeing everything for the first time, kind of again and again, that's where all your reps and your time spent and all that comes into play. Anyway, that's all. I just want to say that here, because I think people, like I said, people say you should spend 15 minutes. Well, in this contest, I don't know. I don't remember the exact breakdown, because I skipped Q3, I think, after 10 minutes, maybe, or 15 minutes, and I went to Q4. So then that means that I spent like 50 minutes on Q4, and I came back and still took 15 minutes and 3 wrong answers to get it, right? And in theory, for me anyway, I knew how to do it. So it's way, 15 minutes is not enough for most people. And even an hour, to be honest, I think it's not. I know that some people even in my Discord would be like, oh yeah, an hour is good. If you don't know it in an hour, just look it up. But I think, you're robbing yourself, if it's not the case where it's named after like some person in the past, like, Larry's algorithm or something. If it's where you can fundamentally do it, I think you're robbing yourself of an opportunity to, having a new problem and testing your problem solving skill, right? Especially on Leetcode, right, where, like I said, a lot of problems on Leetcode, I'm not gonna lie, is just remembering how to do it, at least up to Q3. And this is where a lot of people kind of get stuck on the more difficult Q4s, is that they're like, oh, how do you know how to solve this? Well, did a lot of practice, and I think this is the part where making that transition will allow you to kind of when things start clicking into place. Anyway, all right, I spent 8 minutes talking about this and not the actual problem. I mean, today is an easy one, so hopefully you don't have that much problem, but somehow still watching Larry's, at this point, like I said, it's become like a daily almost podcast, or what was the thing? It's a daily video stream of me just ranting on random things. But anyway, let's take a look. Today's problem is 225. Implement stack using queues. All right, so implement last in first out stack using 2 queues. Okay, the implemented stack should support all the functions of a normal stack. Okay, so yeah, okay, let's get a start on it. So I guess we have 2 queues. What are we doing? So queues by itself, I'm just thinking through the logic. I don't know how to do it off my head, because this is not something that comes up that much in competitive programming, at least not in this explicit way. So yeah, okay, so the thing about stack is that you want to pop out the last item, right? So top, yeah. I was just double checking, because obviously you can use a deck, but if you use a double-ended queue or whatever, obviously you could use a deck, but I think that's not in the spirit of things. I mean, we would use a deck anyway, but only the operations that are supported by the single the queue, right? Because otherwise, this is not a problem. This is trivial and this is silly. Okay, so we have two queues. Let's just define them, I guess. Okay, so push, there's only one operations that you can do. So oh, at most 100 cores. So I guess we can do like linear time things, which I think we might have to. Man, my fundamentals are kind of weak after doing that spiel about learning. I'm like, man, I don't know how to do Q today. I mean, without loss of generality, we can just append one thing because we might have to update this later. Top. Well, I mean, okay. So I'm struggling a little bit. So really, what I'm thinking in my head is, to be honest, I was trying to think through a little bit about the invariant and stuff like this, but to be honest, I was struggling a little bit. Maybe this is just a day. I need to take a nap. I played a lot of sports today, so a little bit tiring. And I'm pausing right now, maybe kind of half stoned because I'm trying to ping out the draw English. And this is kind of maybe one way to kind of think about, at the end of the day, if you're able to solve it, you're able to solve it, and I'm just trying to draw it out. And basically, if you're given two queues, you really only have two things, right? So that means, or you only have two things. Two things. You have two queues, so you have four possibilities, right? So basically, you have two queues. You have basically they're both going in the same direction, but in this case, yeah, let's think about it. Or or you're going, in this direction, and then do something funky with them, or maybe this direction and do something funky with them. Maybe these two are equivalent, and the other thing is just going in, So you have four possibilities, maybe two possibilities. It's not really the same because, I mean, maybe these two could be the same, but the direction also determines what operations you can do, right? Because you can only insert at the end and take out at this end, right? So these two may not be equivalent depending on which way how you handle these. And there are only four possibilities, so we can probably even enumerate through how to handle them. And I'm trying to think whether like there's an all of one thing of this, because I mean, if you do linear, it's trivial in a way, right? But I'm trying to think whether there's an all of one. Maybe I'm just like really blanking out today. Maybe I need a nap. Okay. So here, oops. So now I'm just trying to think through. Okay, what does it mean, right? So push without loss of generality. Like we said, we can just push at the end. But then now we want to peek at the top. What does that mean, right? Well, we can only look at. I'm going to change colors real quick. We can only take a peek here and here for the deck. And again, yeah, in a queue, sorry. Because in the deck, you can look at the end. But if you're using a deck, then you can just actually use the deck as a stack. So you only even need one deck and then just ignore the queue functions. And now you have a stack. So assuming that we don't do that, so peek, and then there's the pop, right? Pop, we want to remove the last item. So let's say we have, changing colors again. We have some, A, B, C. We push these, and then we want to get rid of the pop, right? We want to get rid of here. Man, I am struggling today. if you have a lot of queues, then you could do some kind of skip list thing, but but I think we're not going to get into there. And then now I'm just thinking through for each particular one, what does it mean, right? Because we can only remove these. Yeah, I mean, I know that n is only 100, which is why I think we can do linear. I feel like that's... Oh, I'm trying to figure out whether that is the lower bound, right? Because obviously, that's just trivial otherwise. But... Yeah, I don't know that I can do this in... Because the thing is that if you have 2 stacks, you can implement a queue. But of course, 2 stacks is Turing complete. So you can do anything with 2 stacks, really. But 2 queues, I don't think 2 queues are Turing complete. So maybe it's not true that... because then that's how you get... yeah, that's how you get final state autonomous and stuff. Man, that was many years ago. I mean, maybe. So then now, so let's say we pop the A. Can we reverse the Q? Or maybe another idea is putting it here, and then now we have CAB, and then putting an other thing, then now CAB. Let's say now, and then query this, and then let's say we're under D, then D, and then CAB. That's not very right. I mean, I guess that's right, except for my AB is kind of... but yeah, I guess that's the linear way of doing it, but is that the only way? So basically, let's say you have A, or maybe you have A here, and then now we put B here, and then we do A, and then now let's say we do, and then we move this, and then let's say we C, and then now CBI. I guess man, I am not good with my lower bounds today, because I think if I was better at my lower bounds, then I would know that, you know, that's where if you have more experience of lower bound analysis, then you'll know that if something is a lower bound, then you don't spend time trying to figure out what is possible, right? All right, let me just do the O of N way, and then, you know, basically, yeah, and then we'll see if there's a constant time for it. But yeah, but here then we can just append X, and we can make an invariant thing here as well. But yeah, we have append X, and then now while length of is greater than 0. Q1 dot append self dot Q2 dot pop left, and then now wait, did I do this right? No, whoops. And then now, so then basically we reverse Q1 to put and then append it with Q2, and then we just copy it back so that our invariant is that everything is in Q1, right? And you can only use pop left because otherwise, you know. And now Q1 is the stack, so so now after this we can use pop and top, and that's all you care for. So yeah, so pop, okay, top is just return, or what happens if it's empty? I mean, you could do some kind of yeah. I mean, we could explore this later, but I want to see if there's a linear time or constant time thing. But all the calls are valid. Okay, I mean, I'll just do an assert because I'm not sure. Maybe I'm missing something, but assert length of this is greater than 0. Self dot Q1 dot pop left. So x is equal to this, and then return x. Yeah, and because everything is on top, and same thing here. I'm going to do a little copy and paste, but without the pop left. Just look at the element, and then maybe you even use top in here, but and then here is just return length of self of Q1 is greater than 0. Yeah, I mean, oh, I was going to. Oh, empty. Sorry, whoops. Yep. Give us a minute. Looks good. Is there a way to do it in consonant? I guess not. Oh, I kind of spoiled it a little bit. Yeah, I mean, you can do it with one deck if you're able to do it in linear time for push, because you can see that, if you kind of just visualize it, we kind of put Q2 as an intermediate thing, and then we put it back. So that means that we basically, yeah, so when you have a new element coming in, we put it in the front. So then we just rotate it, an element or something like this. So in this case, we can actually do it, and then for in length of self.q1 minus 1, because we want to subtract 1 from it. Self.q1 dot pop left, and then I don't know if you can do this way. I think this should be good, but maybe not. I don't. Sometimes something's a little bit funky. Here goes submit. Yeah. I mean, this is going to be, like I said, this particular thing is obviously linear, so it's kind of expensive. But if you only have 100 cores, I guess it's fine. But I'm curious whether there's a constant. I mean, yeah, either one of them has to be thing. I mean, you can also optimize the other way, but. Okay, still okay. 1Q. All right, so I guess there isn't any O of 1 for both. I was wondering, but anyway, don't really have much more to add for today. It's a long video for some reason. So yeah, let me know what you think. Stay good, stay healthy, to good mental health. Have a great week, everybody. I'll see y'all later and take care. Bye bye.